So on I went to Sydney Uni, started in 1962, enrolled in pharmacy. And then in the middle of orientation week thought, what am I doing this for? I don't want to be in a pharmacy, so I'll do something a bit broader than this, I'll just do science. So we had the common first year then, I don't know whether it still exists. Anyone who did a scientific course did this common first year, and then you branched out in the second year of university into the course you wanted to do, and mine was science. And that was where I went on and chemistry, chemistry, chemistry. Third year university was chemistry and organic chemistry. So when I had graduated, that was obviously what I was going to do, but no, that's not what happened. Because I had spent every morning going to hour-long lectures, and every afternoon I was in a laboratory. I had done nothing but wear a white lab coat filled with acid burns for about 3 years. I was poor, I was sick and tired of not looking feminine. Chemistry was the last thing I wanted to do when I had finished. Over the other side of the university in Arundel Street, we had a thing called the University Appointments Board. I don't know if that still works in the same way, but we could go in there as uni students, and on great big boards like this, cork board, there'd be all the companies who wanted somebody to work for them would put their little ads up on this board, and computers were new. Nobody was trained in computers. You didn't get trained, you got a job first. And I saw a job with a company at North Sydney, a company called ICT, and I thought, that sounds all right. Getting away from chemistry. Your only requirements were that you had an aptitude. That was it. So I applied for it. In my day, if you applied for a job, you got it. No CVs, nothing. You just pestered them. So I rang, and they didn't call me back. I rang again. I kept, yes, okay, come on in, you got the job, and that was it. So off I went to North Sydney, and on my first day in this huge computer room, which maybe was half the size of that big room I'm looking out there, all the desks, I walked past a room which I never ever went into, but I want to see the first slide because of this, please. This was mounted on a wall like this. There were two of them side by side, and there were two women sitting at a desk down below, and that was a computer. That was called the 1004. And the only way you could program this computer was like a telephone switchboard. You had plugs, and you plugged from here to there, and you got another lead, and you plugged from here to there. I never learned how it worked, but they were programming it. And that was in a room, and that was the earliest computer I had seen, except for things like UNIVAC, which the universities had, and I had no contact with. This room was not air-conditioned, where this computer was kept. It was okay. Anyhow, ICT, in I go, I'm sat at a desk, and in this room there would have been 8 or 9 programmers, one other female, and there were a couple of systems engineers. They were the ones who went out to the companies, and the companies would say what they wanted achieved. It was repetitive work, updating with new information on a weekly, monthly, or whatever basis, the sort of things that mainframes are good at. So I knew nothing about computers at this stage, not a thing. I was given a 1 or 2 week course at ICT on programming, and then put behind a desk and given things to program. The systems engineer would organize some sort of a programming system. You would have an input of some sort where new data came in, somebody would do an update program, and then you'd have a variety of outputs in terms of printouts and putting new information onto whatever storage devices you had. They worked me hard. They worked me very, very hard. I was struggling. I had never struggled in the whole of my life before. I'd always been able to do my schoolwork, my university work, breeze through it all. This was tough, and I would go in of weekends and try to be up to date. This was money, and they wanted to get their pennies out of you. So my husband then, who worked with the Commonwealth Bank, said, They've got the Reserve Bank just up the street from me. It was a breakaway group from the Commonwealth Bank. This was now 1966. We were about to go decimal. Big things were happening in the financial industry in Australia. There were new programs to be written, the Reserve Bank was employing. So I lasted with ICT, and can I see the next slide, please? Programming this thing called a 1301 for 13 months. This was an amazing machine. The way the information went in was either on paper tape or 80-column cards, which were about that size, and they just had holes punched in them, and all the cards would be written in. The actual program would go in on those cards, and once that was in, then the data would come in on cards too, and you'd read them one by one and process your information, and then store it somewhere. Storage, I can't see there, but anyhow, storage was either on magnetic tapes or paper tape. I had nothing to do with the paper tape machines, but you could churn this stuff out, like ticker tape, if you wanted. Just had a series of holes in it. My storage went on to magnetic tape, and the magnetic tapes were about this big, and they were mounted in a machine that was about the size of a door, maybe not quite as high, but quite deep. So they were mounted vertically, because the tapes that we had later on were always mounted horizontally and would feed in from left to right, but this was top to bottom. So that was where it was all stored. I was never allowed in this computer room. All computer rooms at this stage of the game were freezing cold places, because computers would overheat and then they would go down. And computer time was money. It was very, very expensive. So we had to make sure that the computer room doors were kept closed, and also we as programmers weren't trustworthy, were we? We might go in there and do something to muck the whole thing up, and that wouldn't be fair either. So that was the 1301. And the funniest thing about the 1301 was that it was not even compatible with itself. So we would read information in, and in order to print or store, we would have to rearrange the information. So information would come in words of a different format to the words that you would put out again. So we had to write our own little programs to reorder the way things went. It might be, say, 6 alpha, 6 numeric, 1 alpha, 1 numeric, 1 alpha, 1 numeric. We had to write little programs to change all this around to store it on a different type of device. We call these small programs. I have no idea what you do now, so I'm just talking from what I had, and if you do this sort of thing or you understand this sort of thing, just bear with me. But we wrote these little programs called subroutines, and a subroutine is a bit like a macro, and it's something that you can pull in and use again and again and again and not have to rewrite it. Now the problem with all these machines is too, they didn't have much space in them. So if you were writing something and working on something and doing calculations, you did it in RAM, random access memory, which was very, very small and very, very expensive. So what we would do, we pull the information in, and anything that was excessive to our needs, anything that we weren't working on, had to be put onto a storage device. So the whole time we were bringing stuff in, putting it out, bringing stuff in, putting it out. Only what we were actually calculating or moving around or saving, if we could, for immediate usage was in RAM. The next computer I went to, which was the IBM one, had a RAM, I remember the size of it, was 64K. It was considered to be huge. And it was still tiny. I mean, today everything's in gigabytes, everything's there, you can play with it the whole time, do what you like. But we couldn't do this. So anyhow, that's the 1301. I left it behind. I got my job with the Reserve Bank, and in I went in the beginning of 1966. And in order to employ me, they call me a male. I was given male status. This was a big deal. That meant that I could get a man's income, which was hugely higher than a female income. It meant that I didn't have to wear a uniform. So together with the only other female who worked in the computer industry, I would wear streetwear. They would all be in teal blue with white shirts and whatever, so I was very specially treated because of this.
How old were you?
I was 22. And then what happened after that? I married. I'm diverting and muddling things up a bit. I've got notes here. I'll refer to them because I don't want to leave things out. There are a few things I had here. When I married, we decided we wanted to have our own home. So I became the first female at the Reserve Bank to get a home loan. And that was only because I was called a male. If I hadn't been a male, I would never have been able to do such a thing. It's just the way it goes. So off I went into the Reserve Bank. It was the beginning of 1966. Decimal currency was coming in, and there was a whole suite of programs to be written on their machine, which was the IBM 360, which of course I knew nothing about. So I was sent off to IBM, which was the other side of the city, for 4 weeks training. And then back I came. Here's your program, this is what you've got to do. And they had this suite of programs involved in doing everything that involved money in Australia. I had to, as part of the program, pay people their pension checks, superannuation, all this sort of stuff for all of Australia, which at the time sounds, well, at the time it was nothing. And when I think back on it, it had to have been a fairly huge sort of thing to do. But I was ignorant. I never worked in the banking system. I found it very, very difficult. I had never heard of superannuation. I'd never heard of health funds. I'd never heard of anything. I'm 22, and I was given the update program. So I had to handle all the information that people were sort of handing to me. I had to put it out onto some sort of storage device so that whoever was doing printout A could take that information and use it, or printout B could take that information and do it. It was a scary place to be doing an update program at the age of 22 when all I had ever done was go to school, go to university and have 1 year in private industry. Anyway, that was the Reserve Bank. But I'll talk a bit about the, mainframes. The big thing about a mainframe is that it's designed to do batch work, repetitive stuff. It's not used for thinking, which is what computers really do today. You can feed things in and ask the computer to make a decision based on what you put into it. This was still getting the computer to make decisions, but it was just repetitive stuff. So you would have a whole part of a list of clients of some sort, say all males in Australia are over the age of 75 or whatever, and they were to be given special concessions. You have to feed those in and write a program to do whatever it was. But it's batch work. And the mainframe itself was huge. I'm just thinking of, if you took all the pieces of equipment involved in the mainframe and jammed it all in, it probably would fill this room. And again, the room was freezing cold. And again, we were never allowed in. We had people who came in, and actually the engineers would look after that computer every morning between 8 and 9 a.m. We started work at 9. At 8 a.m. they were in there. It was downtime for the computer, and they would be checking everything to make sure the computer would run for the rest of the day. Because if it didn't run, it was expensive. And pension checks had to be paid every fortnight, and other things had to be done. So you had to have this working. It was absolutely essential, or you'd have everybody in Australia down your throat because the work wasn't getting done and they weren't getting paid or whatever it was. We were again in a big room which was divided with things about this high into small rooms, 1 or 2 people in each of these little sections. And you just sat there. And when it came to writing the program, we would write the program on pieces of paper, a bit like A4, But it was all divided up into 80 columns this way because the information all went in on 80 columns. So you'd code whatever it was you're going to be doing on your 80 columns, and then when you'd filled in done your whole program, and you might have pages and pages and pages of this stuff, you'd send it off to the P&V room or the punch and verifiers. First of all, the punch girls. They would punch it all onto 80 column cards. Punching meant the card actually got little holes punched out of it, little rectangular pieces of cardboard were punched out of these cards. And then to check it, the same cards that had already been punched would go off to the verifiers. And they would go through exactly the same work again. It's just, they were like typists, I suppose, and they just would punch all the holes in and then verify that what the first person had done was the same as the work that the second person did, to make sure there were no errors, because if there were errors, your program would crash, and that would be the end of it. So after the program had been punched and verified, and it would come back to you in something like a shoebox with all the cards, there was your program sitting in this box. It would then have to be fed into the computer to run. You had to make sure that that computer was going to run your program perfectly, that your program was not going to crash. I can remember for something simple like just a printout job, you might get 4 test runs. If it was an update, much more complex, you may get 10 test runs. And if you went beyond those number of tests, you're in trouble, because time was money, the computer was expensive. So what you had to do was create a whole pile of artificial data. You had to try to test out everything that your program was expected to cope with. So you'd sit down and invent masses and masses of data which went onto the 80 column cards, and then into the computer would go, and hopefully you would have tested out everything that could possibly go wrong. And you'll probably remember when we turned over to the year 2000, how they had the millennium bug everyone was terrified about. They thought all the programs were going to crash because everybody, they thought, who wrote a program used 6-digit dates, meaning 2 digits for day, 2 digits for month, 2 digits for year, not 8-digit. So the year 2001 crash would have ended up not being a problem. In fact, I'm coming forward a bit because I wrote in COBOL, and at that time they were looking for COBOL programmers, and I thought, am I interested in going back and trying to fix all these programs and put 8-digit dates into them instead of 6-digit dates? Can't be bothered. More things in my life. I was doing other things. So that was what that was all about. Wait a minute, I've just got to...
There's your pen. Pen. There's your photo down.
Oh, he's on to the next one. That's me. This is the 360 at the Reserve Bank, and in here, this is actually teal blue. This girl Ella and I were the only 2 female programmers. We had a heap of male programmers in there. And then here is one of the operators, and the systems engineers who probably hang around there too. And this is obviously a posed photograph. Firstly, we're in the computer room. You shouldn't be in the computer room, but it was done for their monthly magazine that came out called Currency, and that was put into the magazine. So there we are. You can see I'm not in uniform, so it was wonderful. I took advantage of it. We started off with magnetic hard disk drives in the Reserve Bank, and one day we were told we were going to get disk drives. And it was like, my God, isn't this incredible? Because using a magnetic disk drive, everything went on serially. So if you were trying to get something off a tape, and it was at the end of the tape, you had to read the whole thing in, and that took time, and that was money. But when the disk drives came in, they were in packs of 6 disks with read-write arms that would go in. And it saved a huge amount of time because these read-write arms would sort of be going in and out, and they could feed onto any one of all the 12 surfaces. So it's much faster access. So they were incredible things. And they were about this big and stored in big boxes, and they were carried around very heavy. So that's about as modern as I got in all my time in the Reserve Bank. I programmed in, oh, that's what I want to tell you about. Going back again to the 1301, we programmed in machine language. So if I wanted to, it was learning a whole new language, but not letters, it was numbers. And was trying to remember what the numbers actually were, but I think a 32 meant move. So if I want to move something from A to B, I would put 32 and then an address to an address, whatever it was. When we got to the Reserve Bank, I was into a sort of a semi-English language, at least it was letters, and I was programming in COBOL. And I remember this for sure. MVC meant move. EOJ, end of job, EOF, end of file, all that sort of thing. And what I remember too is at that time all the cars in Sydney had 3 letters, 3 numbers. And I'd be looking around at all their number plates. Oh yeah, EOJ this and EOF that and MVC something else. All the words that I used in programming were the 3 letters on the number plates of all the cars. It was a constant reminder the whole time that this is my programming. So that was that. I think I've probably just about said it. But what happened in the end, this was 1971, and I've been programming at the Reserve Bank now for about 5 or 6 years, and I became a mother. So married women with children, didn't work, end of career. Went home. Didn't go back to computing again for a long, long time, thought about it occasionally, had a heap of other careers that I pursued along the way. In 1989, having done a year at university again, I got a diploma of education and became a school teacher. So I got into the high school system and became a teacher of chemistry and biology at my local high school. And then one day they were looking for a computer teacher. And because I had been a computer programmer 40 years earlier, I became it. I only had to be 1 lesson ahead of the kids. You all know that, any of you who have taught anybody. You've only got to be 1 lesson ahead of them, and then, you know, all is well. The bit I liked best was flow charting. We really enjoyed that in class, and I had a lot of fun with the kids flow charting. But of course, anything that I had learnt just didn't even exist anymore. So when it came to programming, I think we got into some simple stuff on BASIC, which I had to learn. I'd never done anything like that before. And I taught computer studies for a few years, and I can remember that one of my students actually got a career as a computer something or other, highbrow, earning lots of money, and I was pretty proud of that. So that was sort of it, really. That was my career in computers. I stayed as a teacher then. I became a teacher when I was 45. I retired at the age of 57. And since then, just done a heap of things. And I guess right now, my interests are cooking, travel, grandparenting, gardening, family, and anything to do with computers and all these things that drive you throughout a whole of your life have gone.
Except for your bridge.
Oh yes, bridge, that's another one. I love bridge.
Very good bridge.
Yes. I had to, well, when I retired, I figured there are really 3 facets to people. There's the physical side of things. So I'd already been going to jazzercise a few times a week. I kept that going, still do that. Then there's the brain, the mental side of things. I thought, do I go and teach part-time or do I find something else? But I discovered bridge. And bridge as a card game is extraordinary, so I have a lot of fun with that, so that keeps the brain going. And the other thing was the emotional, esoteric side of things. I thought art. So I started going to life drawing classes and I just didn't have time for it all. So the life drawing went, the art went. I mean, it's all there, all the paints and the brushes or everything is still at home. One day maybe I'll pick them up again. But for now, I've got it for the brain, I've got it for the body, and everything else you know. I don't think there's much else I can say, and I hope I filled in half an hour, because that was what I was supposed to do. What is the time?
Yeah, we have time.
Well, any questions then, if we've got time?
Just when you went back to teaching, was all your chemistry knowledge still there? Did you forget it all?
You know what? The funniest thing about things that you learn in a lifetime is that you don't forget anything, but the pathways get rusty. So if all you have to do is read it up again, and it flashes back into your mind, it doesn't take long. But I had forgotten a lot. And now it's 17 years since I've retired, and if I try to think of some of the chemistry that I taught, I am rusty. But if I pick up some textbooks, because I've kept a few, and flip through and think, yeah, that's right, that's right, that's right, I can remember this, but I don't use it. So use it or lose it. But it can all come back. Yep.
So before you were talking about the data cards that you're using at IBM and that they were all 80 columns?
80 column
80
cards.
cards. Was this globally the case, and do you know if that linked
Well, I
to
believe there were 40 column cards too. But yes,
Oh, okay.
globally I think that was probably the way it was.
Because I was wondering if it was related to the old Fortran code being limited to
Fortran
76.
would still have been punched into an 80 column card to get the
Right, which
information into the
explains-
computer. It had to be fed in somehow. Paper tape, so
Yeah,
there were,
probably.
yeah, you either got your program put on paper tape or you got it put on 80 column cards.
And Fortran was always on the 80 column card?
Fortran I know so little about. I tried to learn a little bit of it. It's very, very abridged. It's not as friendly as COBOL. Because COBOL, common business-oriented language. Fortran is a university thing for mathematics. I looked at it once and I thought, wow. But no, I never ever did anything in Fortran, so I really can't answer that more than what I've said so far.
I'm just curious
But
because
yes, I
that,
think
the
the
number
80
is,
character line length, I think, is
that might be
is-
linked to the 80 column
is linked
length,
back
yeah.
to punch
They're saying
cards.
some cards at the time were in 40, some in 80, and some
Yep.
was on the magnetic tape.
But that also got
It had to
transferred
start off
terminals.
getting into the computer somehow,
Yeah,
and that came in on card.
on card.
Yeah.
Do you know how much data could be put on a single
80
card? 80
characters.
columns, and
Just-
not
And that
rows,
was just
80
divided.
bytes.
Oh wow, that okay.
Yeah. You could put a character in every column.
And is that more than in the first photo you showed us, the 3010?
The, both my
The
computers
card.
were 80 column card
They were,
operated.
Yeah.
But the first one, the one at ICT at North Sydney, had paper tape machines as well, which I never had anything to do with.
Right.
But the paper tape was always tearing. Was shocking stuff, so the programs would always crash. So I was pleased I had nothing to do with paper tape.
Yeah. And the magnetic tape, would that hold any more?
What was that
The
about?
magnetic tape, would that hold more information?
Oh, magnetic
or-
tape held a lot of information. That was your storage device. Once you got the information into the computer, it could be stored on magnetic tape. That was fine.
Okay.
So
And
you
then,
would load
so
your
you
subroutines.
send it up, sorry, you'd send them updated information, say, off to a tape, and at the same time you'd be doing printouts because the company would want to know how well they'd done last month or,
Yeah.
you know, what their projected orders would be for next week or whatever it happened to be. But you'd have all the updated information on a magnetic tape, which next week or next month when you ran the program, you would feed back in and update
Yeah.
and feed it back again. Yep.
I was just saying that I presume you would load your subroutines onto a magnetic tape so that they could be reused. from
Your
there, or would you-
subroutine was written into your program. You had it there and you could pull it down. It would have to have been on the tape or in RAM. It had to be in one of the two when you were using it, and then you'd shovel it off again, get it out of the area that was expensive and limited just for storage. But it was in, out, the whole time. You couldn't just have everything lying there, oh yeah, you want to use that bit or this bit or whatever it happens to be. You could only have in your operating area a very limited amount of information. So, for instance, this might be the area you're working in, and all this is storage. This is inactive. So, if you've got something you don't need for a little while, you put it out there. Then you bring something else in. Because this was so small and so limited, we couldn't waste space by having stuff that wasn't actually being used in there. Did that answer it? I don't think it did.
Yeah,
You
no,
got a puzzled look on
think
your
it did.
faces.
No, 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 I think it did. I think we need a little bit of imagination to understand, you know, how you went about retrieving things from a tape that you might want to reuse again. Or
Read.
retrieving things.
Read.
Yeah, you read it, but you have to read it in order. So you know you need to go back to the
You
start.
read
and
until you
then
get to a marker where your information is stored, and then
Yep.
yeah.
Yep.
So you had start markers and end markers.
So
But I
as
can't
you-
remember how we did those.
When were you doing you were teaching in basic in which years?
I did
The-
Oh, I taught in basics, let me see, probably was in the late, I retired in the year 2000.
Okay.
So it would have been in the late 90s, 1995 to, but this was just stuff for year 10 kids.
Yeah, but one thing that I was reflecting on from your experience was how little opportunity you would have had to do trial and error, right?
Very little
And
opportunity,
that
it
is
all had to be done in your head.
Yeah, so these days, most people, I would think, or at least children, you know, picking up programming, but also adults, are
They
trying
test on the
something,
computer as
seeing
they
what
go.
happens.
Yeah.
You know, if it crashes, that's all right. Start again. You know, tweak something, see if it goes. If it goes, and you know, from the sounds of things, in your case, you not only had very few opportunities to
Very
try and experiment and see what would happen, but that maybe the effects of writing something that didn't work perfectly.
Emotionally, it was huge.
Mm.
If your program crashed, if you'd been given 4 chances of getting this program right and you didn't, you're in trouble. So you have to falsify, make all this data, dummy data, and test it in your head. So you'd be sitting there with your flow charts and your coding and, you know, if this, do blah, if not, do blah, and so on and so forth, and you'd have to be running through it all.
Walkthroughs.
Unit tests.
I don't know how you
No,
flow
the thing is, that's different from unit tests because she's not actually running it.
Yeah.
Oh,
So
no.
that's
Running it
what
in her
I
head.
thought at first, that there was actually test cases that you would run, but no, these are
No,
work
never, ever did we run it ourselves.
walkthroughs.
We don't do that nowadays, we just run it and see what happens.
Yeah, no, you
Yeah,
send it off to the computer room, and when you got to your desk the next morning, you'd know whether it was working or not. Wasn't good.
I can see like the various utilities and pros and cons of using the paper cards. I guess I'm wondering, did you ever lose? Like you have a whole stack, your program is a stack of cards.
Did it ever get dropped?
Did you lose a card, get them out of order,
Yes.
they rip?
Yes.
How did you?
It was fraught with problems.
These days
It
you
really
use
was.
V-sticks or which direction
Yeah.
you put something in or which machine it's on.
Yeah, it was bloody.
But I guess you had your originals that you had written out.
Well, I've got everything written on my sheets the
Yeah.
whole time.
You can always
And
recreate
I've only
a lost
got one
card.
copy of my program.
Yeah.
It was very precious. Not just to me, but to the people who ran it.
Commonwealth of Australia.
Was it?
So what does it store in pigeonholes, like the different like groups of cards? Or were they?
I think they had this big metal cupboards with blocks.
Yeah.
Store them in there. They would be loaded into, well, they would be loaded in, and I guess that was the original. It's all starting to flood back. Remember, this is 50 years since I've done any of this. It would be stored in the cupboard as a primary source of being able to get it back up and going again if you wanted to. But it was also stored on magnetic tape. So it would come in, it would be loaded, and the whole thing would be stored out on magnetic tape somewhere. But I never saw that process.
Yeah, no, it's interesting.
I could look through the glass windows what was going on in the computer room. It was a funny system.
So with your coding, was it competitive in a sense that you, I mean, people, or was it collaborative? Did you share different code snippets and help each other
No,
out?
they didn't share.